Hello friends, welcome to Catalyst Chemistry. As we discussed last video, the introduction about atomic structure. In that we have studied what is atom, what is element, what is an element, and next one is what molecule, next one is what matter according to what Dalton atomic theory. You know very well about the atom cannot be created, neither be created nor be destroyed. Okay, all those points most important, bear in mind. Okay. Next after that what the atom is divided means what atom further subdivided into what three category, 3 to 4 category are there. First one is what electron, proton, next one is what neutron. In your syllabus only they are mentioned what electron, proton and neutron discovery, means these three are what major role in what subatomic particles for what atoms. Okay. In that first point we are going to study about what is that means discovery of an electron. Okay, just here this electron is a subatomic particle, no problem. Okay, heading is subatomic particles. In that first one is what discovery of an electron. After that we are going to study about a discovery of proton and discovery of neutron. Okay. Next in this case discovery of electron is there. Discovery of electron with the help of cathode ray discharge tube. The heading is what? Cathode ray discharge tube. If you want you can write a tube, no problem. This cathode ray discharge tube is present in what television. Okay, if you know the picture we are going to see about in a television, in that you are going to get a what fluorescence, you are going to get a color. Why you are going to get a color? That television having a what fitted what, that is cathode ray tube. Okay, bear in mind that is most important point. Okay. If cathode ray tube is spoiled, that time you are not going to visible correct what is that picture. Okay, that is most important, that is automatically it is what invisible. Just here in this case also they are going to use, means it initially scientists also very difficult task for discovery of an electron. That time they are made a plan, that is what they are going to use a what cathode ray discharge tube. They are going to make on setup. This is indicate what one setup for discovery of an electron. Just here friends, the most important diagram here, they are going to consider one tube. This is a what tube. Okay. This is what cathode ray tube, generally called as a tube. In televisions also present same tube only. Okay, just here they are going to make a two end. The one end is a what negative charge, the another one is a what positive charge. Okay, if negative charge is there, they called as a cathode. Cathode means most important negative charge. Next, if anode is there, that is what positive charge. After that this is connected with what high voltage battery. High voltage battery approximately they are going to use what 10,000 volt battery. This is indicate what plus, this one is indicate what, sorry, this is minus, this one is indicate what plus. Just here in this case very small is there, that is indicate what negative. If large line is there, that is indicate what positive. This negative is connected into what negative. Next this positive is connected with what positive. Okay, this one is what battery. Okay, they are going to use high voltage battery. Next this is what discharge tube is there. Next after that they are going to fitted with one to vacuum pump. To what vacuum pump. Vacuum means what in this case empty. Just you are going to open this. This is we are going to call as the knob, K-N-O-B, knob. Okay, just you are going to open the knob, the gas will go out. Okay, if you are going to fill the gas with the help of the vacuum pump, you have to fill. Okay, just here in this case this tube containing gas, what kind of gas is it? The gas is what they are going to use, generally helium gas. Okay, just here in this case this is what gas at very low pressure. They are going to maintain very low pressure. If you are going to maintain high pressure, means what in this case the means what there is a difficult for movement of an electron. That is why they are going to use a very low pressure. Low pressure means what in this case low pressure means which gas they are going to use? Helium gas they are going to use. Okay, helium converted into, I will tell you. Okay, just see here. In this case what this one is what tube, this tube is having what helium gas, that helium gas is almost a low pressure they are going to maintain. Okay, next after that when you are going to supply, this energy, means this is one type of also energy. When you are going to supply the current or energy, means we have a battery, that is high voltage battery, approximately 10,000 volt is there. That time you are going to pass, in this case gas is there. gas is there. In this case what happen, they start, means what, the cathode line, cathode electrode start emission of what, straight line, emission of what, straight line rays. Those rays are called what, cathode rays. Just here in this case what, the cathode rays are what, indicate negatively charged particles. Initially they know the negatively charged particles. Negatively charged particles indicate what, electron. The negatively charged particle indicate what, electron. Initially they do not know the electron, but initially they know the what, these rays having a what, negatively charged particle. How they come to know the rays having a negatively charged particle? Very simple. Just see, they know this is having a what, negative, this is having a what, positive charge. All these are indicate what, invisible things. All these are indicate what, invisible things. Okay, that is why most important point is in this case what, gas. It start emission of what, straight line. This straight line will move from cathode to anode. They move from cathode to anode, automatically they will come to conclusion, okay, these rays having a what, negatively charged. Finally they thought that what, 100% in this case what, negatively charged move from what, cathode to anode, not anode to cathode. Okay, this is most important. If the rays start from what, anode to cathode, means they called as a positive, but in this case not like that. The rays move from what, cathode to anode. That is why they called as a what, the most important is what, that is negatively charged particles. After that they called as a negatively charged particles called electron. They called what, negatively charged particles called what, electron. This is final conclusion. Okay, just here most important, just here in this case what, they are going to use the helium. The helium gas start moving from cathode to anode. The helium is converted into helium plus, the loss of an electron. The helium plus, next one is what, loss of an electron. Hydrogen, helium, the atomic number of helium is 2. Atomic number 2 means what, that is a proton is 2. Next in this case electron is also what, 2. They start emission, their helium gas start emitting the radiations. These radiations having a what, 1 electron, helium plus, next one is what, loss of an 1 electron. This 1 electron indicate what, negatively charged particles. Okay, that is most important. This is a what, totally experimental. This depends on what, totally cathode ray discharge tube experiment. Okay, up to this they are going to ask you what, explain cathode ray discharge tube. We have to write all these points. Okay, the next important point in this case what, this point only. In this case what, observation. Okay, in this case what, some of the points they come to conclusion what, after observation of what, cathode ray experiment. Okay, just here in this case the first important point in this case what, in the absence of electrical or magnetic field, these ray travel in a straight line. Okay, now only I told these ray travel in a what, a straight line. Okay, that is why they called as a cathode ray tube. In by chance, what is the title is there in this case, absence of what, electric and magnetic field, most important, absence. In this case there is no electric and magnetic field, the ray moves straight line, no problem. First point is what, clear, no. Okay, next second one is, in the presence of electrical or electric and magnetic field, the cathode rays gets deflected from their straight line path. They start deflecting. Just here I will tell you, don't worry about that point. In this case I am going to fit it with what, magnetic or a electric field. Okay, this tube is there. In tube side only I am going to make a setup. Okay, this is indicate what, electric or a magnetic field. You have to use any one of. Okay, at a time you have to use any one of. If you are going to use a magnetic, in both cases you have to use magnetic or you have to use electric field. Okay, next after that they start experiment. By chance. In this case what happens, these rays will not move a straight line. The rays will not move a straight line. Just here in this case, this one I am going to consider positive, this is I am going to consider negative. Okay, scientists initially they are know these rays are negatively charged particles. Okay, they are going to use, by chance they are going to use a magnetic field or electrical field. In this case what happens, these rays will not move straight line, the rays start towards bending. towards what? Positive charge. The rays start bending like this. Okay, the rays start bending like this towards what? Positive. Just here in this case positive is there, the rays are what? Negative. Oppositely charged attract each other, the same charge start repel each other. Okay, here negative is there, here is what? The incoming rays also negative, the negative start repulsion. Automatically in this case what happens? The rays completely bend towards what? Positive charge. When they are going to use electric or a magnetic field, that case only. If they are not going to use, the rays move a straight line, no problem. Okay, the second point is what? Clear. Okay. Next, third point. The nature of the cathode ray particles remained the same whichever the substances was taken in the gas discharge tube. Okay, in this case most important, they are going to use a what? Helium gas. Next they are going to use a neon gas, radon gas, like this nitrogen gas also. That time the rays move straight line only, absence of what? Electric field. Means if you are going to change the gas, the rays will not going to change. Okay, this is most important. Whatever gas you have to use, the rays will not going to change its direction. That is most important point. That is what? Third point. Bear in mind. Okay, these 3 points are most important. These 3 points come to conclusion with the help of what? Observation. Okay, next most important point in this case, what? That is called what? With the help of all these things, finally we are going to come to conclusion, means what? The discovery of an electron. The electron discovered by what? The most important J.J. Thomson. Okay, the electron discovered by what? J.J. Thomson. Okay, name of scientist. Okay, J.J. Thomson. Okay, most important. Sometimes they are going to ask you in public exam, who discovered the electron? Your answer must be a J.J. Thomson, the most important point. Okay, that's why you have to make it note down. The who discovered the electron discovered by what? Thomson. In this case the final conclusion means what? In this case final conclusion is what? Finally we are going to derive the electron. Okay, with the help of what? Cathode ray discharge tube. Next important point in this case, every atom, means what? In this case they are going to use a gas, means just here they are going to use a helium gas. No. Okay, this helium gas having a what? Electron, neutron, next one is what? Proton. All subparticles are present in what? Helium gas. The final conclusion means in this case every atom, this helium is what? Atom. Just I am going to write a helium 2. This is indicate what? Molecule, but this is not exist. We will study later in chemical bonding and molecular structure. Okay. The final conclusion in this case, every atom having a electron. The every atom having a what? Electron. That is the most important point. Bear in mind, I am going to write here. Just here the final conclusion is every atom having an electron. Most important point. You have to take every atom, means how we are going to say every atom having a what? Electron. Just I told, no, if you are going to change the gas, means in this case I am going to use a helium gas, I am going to get a same. I am going to use a neon gas, I am going to get a same straight line only. I am going to use the radon, I am going to use a nitrogen gas. Okay, that time also I am going to get a same. But the condition is you have to maintain low pressure. Okay, that is most important point. If you are going to maintain high pressure, means what? The rays start bending. Okay, that is most important point. Okay. Up to this is indicate what? A discovery of an electron, J.J. Thomson. Okay, next important point is there in this case what? The mass ratio. Mass ratio we are going to study. If you want, you can take a screenshot. Okay, I will tell you mass ratio. Okay friends, listen here. In this case what? The next one is what? The most important is what? Charge of an electron. Next one is what? Mass of an electron. We are going to find out. Just here. Cathode ray tube and applying the magnetic field. Cathode ray tube is there. In this case they are going to applying the magnetic field. That time applying the magnetic field, the ratio was found to be. Okay, this is experimentally, do not worry about this one value, just you have to remember the E divided by, this is called charge of an electron divided by mass of an electron is equal to 1.76 into 10 to the power of 11 coulomb per kg. This is what? The cathode ray what? Applying the magnetic field, we are going to get this value. Later, after some time later, R.A. Millikan determined the charge of an electron. Okay, the electron discovered by J.J. Thomson. Next one is what is the charge? That is also most important. No? That's why in this case what R.A. Millikan determined the charge of an electron is what the most important, minus you have to take because electron is negative, minus 1.6022 into 10 to the power of minus 19 coulomb. This is most important, bear in mind. They are going to ask you very simple 1 marks question, what is the charge of an electron according to what R.A. Millikan. That time you have to write minus 1.0 minus 1.6022 into 10 to the power of minus 19 coulomb. Finally, the mass of an electron, this is what charge of an electron. The next one is what is the mass of an electron, that is also most important. Mass of an electron is equal to E divided by this total, when they are going to apply the magnetic field, here is there no, the ratio was found to be charge and mass of an electron, that is E divided by mass of an electron is equal to 1.602 to next into 10 to the power of minus 19 coulomb divided by 1.76 into 10 to the power of 11 coulomb per kg. This coulomb get cancelled because coulomb will go off, means per coulomb, coulomb and per coulomb get cancelled. Finally, per kg is there, no, it will go off, that is act as a kg. Finally, the answer is what 9 point, the most important, bear in mind, okay, 9.109 into 10 to the power of minus 31 kg. Don't worry about entire these things, just you have to remember 2 points. The one you have to remember directly, what is the charge of an electron, minus 1.6022 into 10 to the power of minus 19 coulomb. Another point you have to remember mass of an electron, that is 9.109 into 10 to the power of minus 31 kg. These 2 points are most important. Don't worry about remaining things here, just you have to remember 2 points. Okay friends, up to this what discovery of an electron and next charge of an electron, mass of an electron is completed. The next point we will study next video. Thank you, subscribe and promote the channel.